I have been recording the lessons now, so you can go ahead under Mrs. Everhart's link for YouTube. My link is right under there for my YouTube. Someone please go on tonight and just make sure that they're up there and you can review them. So if anyone does that, please do that tonight. Take 30 seconds, see if my link works, and that the videos are actually posted. Alright, and also, Mrs. Everhart got her flowers on Friday. She was very, very appreciative. She texted me and was so grateful and thankful that you guys pitched the money. She was really touched by the kind words, so just let you know that she loved the flowers and the chocolates. Really appreciated the card and whatnot. So she's thinking of you guys and definitely misses being here. So today, I think we're on page 5 of our notes. 5? Okay. So today, we are going to be converting from degrees to radians and radians to degrees. Okay? And we'll have lots of time at the end to go over homework problems. Okay? So, if I'm looking to convert 180 degrees into radians, my formula that I'm going to use is going to be, I'm going to multiply my degrees by pi over 180. That is the conversion to go from degrees to radians. So if I do 180 degrees times pi over 180, that's 180 pi over 180, which is just pi. That should be no surprise because yesterday we talked about 180 degrees being half of a circle. You also remember, excuse me, if I do a full circle or one full revolution, that was the same thing as 2 pi radians. So if I go halfway around the circle, I'll have pi radians. For 45 degrees, when I convert, I multiply 45 times pi over 180. I get 45 pi all over 180. Does everyone know how to do the simplifying fractions in their calculator? You type in the calculator, hit math, number 1, and it will simplify 45 over 180. And that is pi over 4 radians. If you want to have your calculator out, we're going to do more calculator problems as well. So in number part A, B, C, and D, all you're doing is multiplying by pi over 180. Pretty straightforward. So like 210, multiply by pi over 180. That's going to give us 7 pi over 6 radians. For 270 times pi over 180. If you want to do this work, you can. You have 270 pi over 180. And that will simplify to 3 pi over 2. For 300 degrees, again, I'm just going to multiply 300 times pi over 180. And that's going to give me 5 pi over 3 radians. And the last one, 360, that's one full circle. That is 2 pi radians. Because 360 times pi over 180, when you simplify, you do get 2 pi. For the homework tonight, you're going to do something very, very similar like this. So here, now to go from radians to degrees, it's actually very similar. Instead of multiplying by pi over 180, we're going to multiply by 180 over pi. So when I take 3 pi over 4 radians. 3 pi over 4 radians times 180 over pi. Well, here, if you want to simplify across, kind of like what we did in the last chapter, this screen is not. My pi's will cancel out. I'm going to have to readjust here. So if I do 3 times 180 over 4, what does that simplify to? You can put that in your calculator real quick. What have it? Go ahead, Stephen. We get 135. So it's 3 times 180 all over 4, which is 135. Okay. Pi over 2, to convert that to degrees, multiply by 180 over pi. Here, you can think of the pi's will cancel out, and I'm left with 180 over 2, which is just 90 degrees. That should be no shocker. We talked about that yesterday, the 90 degrees. That is 1/4 of the way around the circle. So here when I'm looking at my practice problems, pretty straightforward. We're just multiplying now by 180 over pi. You can use your calculator for sure. So I have 5 pi over 6 times 180 over pi. If it helps you to think of that the pi's cancel, you can do that. So then this will be 150 degrees. Same idea for pi over 3. Pi over 3 times 180 over pi. That's the same thing as 180 over 3, which would be 60 degrees. Five pi over 4. When I have 5 pi over 4 times 180 over pi, I get 225 degrees. The last one, 3 pi over 2 times 180 over pi. That will give me 270 degrees. Pretty straightforward with conversions. All you have to do is remember 180 and pi over 180. Does everyone have their graphing calculator here? Okay. So for the next part, we're going to look at evaluating radians and degrees in our calculator using trig functions. So your calculator actually has 2 different modes. It has radian and degree mode. So I'm going to pull up a calculator here real quick. So if I need to find, the first problem was sine of 45 degrees. If you hit mode on your calculator, and then the third line down, if you see the radian and degree, if I'm evaluating a degree of a trig function, my calculator has to be in degree mode. So make sure that the degree has like the dark black underneath it. So when I'm asked to find sine of 45 degrees, I get 0.707. If you notice here, if your calculator was in radian mode, sine of 45 radians does not give you the same answer as sine of 45 degrees. Okay. So it's up to you when you do homework problems, if you do all the degree problems first and then all the radian problems. But like I said, your calculator has 2 different modes. So you just go into the mode button right here next to the second button. So mode, and then you can easily convert from, it says radian and degree. Okay. Any questions on the calculators? Okay. All right, so help me out here. Sine of 45 degrees we said was 0.707. Okay, what about cosine of 300 degrees? Who has that? Charlie?
0.5.
Yep, 0.5. Let's keep in degrees. Tangent of 0. Zero. Next, tangent of 240. Austin? 1.73. Still off. Okay, now for cosine of 2 pi over 3 and sine of 11 pi over 6, we have to be in radians. Make sure you're in radian mode. You can tell me what cosine of 2 pi over 3 is. Now get in your calculator. Charlie, what'd you get?
Negative 0.5.
Yep, negative 0.5 or negative 1/2 in sine of 11 pi over 6. Got it, Charlie?
Negative 0.5.
Yep, it's also negative 0.5. Any questions? How to convert from radians to degrees, or vice versa, or the two different modes on your calculator. So tomorrow for the quiz, showing you right here, right now, I would study the circles that we had on page 3 of our test, and you tell me it's all going to be in radians. Okay? You tell me right above we're 90 degrees, you tell me what radian that is. And then there's nothing on coterminal angles. So a lot of your homework problems just said sketch 3 pi over 2. And you sketch that angle. And you tell me if it's a positive angle, you're drawing your arrow counterclockwise. If it's a negative, you should be drawing your arrow clockwise. Okay? It'll take 10 minutes. It's going to be 8, 9, 10, 14 points. Pretty straightforward, 1 point for each answer. Let's go over homework then. I'll start with questions from the crowd. What questions do we have? We have 13 through 27 odd, 83 and 85. Okay. For 23, I'll do the 3 we were supposed to present. For 23, we're given a radian of 4. Well, if you were to label your axes, instead of using pi, like 3 pi over 2, pi is approximately 3.14, and 3 pi over 2 is approximately 4.71. So when I sketch 4, it has to be in this third quadrant between these two values, and it's positive, so my angle is going this way. So here, if I'm given -3, it's going to be in the same position, but going backwards. For 25, you're asked to find positive and negative angles, coterminal angles. So for 25, if we're given pi over 6, I can add and subtract 2 pi. If you need to do this on the side, 2 pi, since I'm given 6 as my denominator, that's the same thing as 12 pi over 6. So pi over 6, when you add 12 pi over 6, you get 13 pi over 6. That's another positive coterminal angle. And when you subtract 12 pi over 6, we get negative 11 pi over 6. For B, we're given 2 pi over 3. I can add and subtract 2 pi to help find positive and negative coterminal angles. Well, 2 pi, I have thirds as my denominator. That's the same thing as 6 pi over 3. So instead of adding 2 pi, you can just add 6 thirds. It's the same thing as 2. So when you take 2 pi over 3 and add 6 pi over 3, we get 8 pi over 3. And when I have 2 pi over 3 and I subtract 6 pi over 3, I have a negative 4 pi over 3. Okay. For 27, I'm given negative pi over 4. Well, 2 pi, if I'm given fourths as my denominator, that's the same thing as 8 pi over 4. So here in this case, when I take negative 9 pi over 4 and add 8 pi over 4, I still get a negative angle. I get negative pi over 4. So if I go ahead and add another 8 pi over 4 to this angle, I will get a positive 7 pi over 4. And B here, I have negative 2 pi over 15. Well, 2 pi, if I want 15ths as my denominator, 15 doubled is 30. So 2 pi is the same thing as 30 pi over 15. You could have had different answers for any of these problems. There's infinitely many coterminal angles to our given angles. Or any other questions? You have the next 10 minutes to go ahead and work on either your corrections to your tests. You can work on the homework for tonight, the book work. You also can work on your yellow triangle packet, which is due on Friday. If you have questions on that, please see me. I've already had a couple people. I know we did some example problems together already. Yes. Yes. Or you can work on the book work. I have 2 people to present tomorrow, 65 and 120. Steven, 65. Charlie, you've presented a lot already. Let's get someone who hasn't. I'll randomly pick someone that I know hasn't presented yet this semester. Maya, you want to do 120? This homework is just converting the radians into pretty straightforward.